So imagine, just for a second, that you actually have a digital twin.
Oh, that sounds very sci-fi right off the bat.
Right. But I'm not talking about like a metaverse avatar or some virtual reality character you play games with.
Okay, so not a video game.
Definitely not.
Yeah.
Think of a 24/7, completely invisible duplicate of your actual health profile.
Oh, wow.
Yeah, and this twin, I mean, it never sleeps. It continuously monitors your vitals. It notices when your blood pressure ticks up just a fraction of a degree,
Right.
and it actually fixes problems. Like ordering a replacement part for your home medical device before your doctor even knows a problem exists.
That's incredible.
Before you even realize it's a problem, really.
Yeah, I mean, you hear that description and you immediately picture a futuristic medical drama, like where everything is run by supercomputers.
Totally.
But the fascinating element here is that we are not discussing a theoretical concept slated for, like, the year 2050. We are looking at architecture that is functioning today.
Which is just mind-blowing. And welcome to the deep dive, by the way. Our mission today is to explore this massive paradigm shift in technology.
It really is a shift.
It is. Specifically, we're looking at how we can transition systems from being a passive database,
Huh.
essentially just a highly expensive digital filing cabinet, into an active participant.
Exactly.
We are talking about a system that observes, thinks, and can literally save lives.
It represents a profound shift in how we approach data. I mean, for decades, technology has primarily been used to just record what has already happened.
By looking in the rearview mirror.
Yeah. But now we are moving toward predicting and managing what will happen next.
And to guide us through this transition, we've got a phenomenal stack of sources today.
We do.
We are looking at a proof of concept guide. It's titled The Autonomous Care Coordinator. And alongside that, we actually have the trailblazer profile of its architect, Raksha Sanganee.
Which is great to really understand the mind behind the build.
Exactly. And setting the stage with Raksha's background is critical here.
Oh, absolutely. Because her specific expertise, it completely informs the brilliance of this architecture.
Right.
She is a solution consultant at Fluido Infosys over in London with over 4 years of really deep, specialized experience.
So she knows her stuff.
She really does. She builds custom Salesforce apps, runs nonprofit success pack programs, and has extensive experience with Capado and DevOps.
Well, let me just pause on those last two terms for anyone listening who might not be deep in the developer trenches. Right?
Yeah.
Because when we say DevOps and Capado, we are really talking about the plumbing of software development.
That's a good way to put it.
Yeah, I mean, DevOps is basically the practice of getting code out of a developer's brain and into a live system without breaking everything else in the process.
Which happens a lot more than you'd think.
Right. And Capado is a specific tool used in the Salesforce ecosystem to manage those complex deployments. So looking at her background, it tells us she doesn't just design pretty concepts on a whiteboard.
No, she knows how to build them so they actually survive in the real world.
That is such a vital distinction. And speaking of surviving the real world, this proof of concept wasn't just like hidden away in some corporate vault as a proprietary secret.
Not at all. Raksha published this definitive guide right in the UK Salesforce consultants and contractors community on LinkedIn.
Oh, wow.
Yeah, and she is actually a co-leader of that group.
Which gives the document immense credibility, right?
Yeah.
Because this is peer-reviewed, community-tested architectural thinking.
Exactly. It is an architect talking to other architects and developers about what actually functions when the system is put under real pressure.
So let's get into it.
Yeah.
And I think the journey of how she arrived at this autonomous care coordinator design is, well, perhaps just as instructive as the final product itself.
I completely agree. Let's start with that initial request.
Yeah.
Because I think anyone working in tech, or really any client-facing business, is going to find the beginning of this project intimately familiar.
Oh, for sure.
The stakeholders came to Raksha with a very specific, simple ask. They just said, can you build us an AI chatbot to answer basic healthcare questions?
Okay, let's unpack this. Because my immediate reaction to that request is a bit cynical, to be honest. Right. Because if you are a hospital or a clinic and your patients have complex chronic conditions like heart disease or diabetes, a basic FAQ chatbot is essentially just a digital Band-Aid.
Yeah, it really is.
We all know the experience of interacting with a generic chatbot. I mean, it is helpful if you have a minor scrape. It's like asking, what time does the pharmacy open?
Right, simple things.
But it is completely useless and, frankly, frustrating if the engine of your health is actually failing and the bot just keeps pointing you to a generic help article.
Your cynicism is entirely justified. And it actually aligns perfectly with the realization Raksha had during the discovery
Oh,
phase.
really?
Yeah, because an architect's job isn't just to build what the client asks for, The real value is in diagnosing what the client actually needs. So rather than jumping straight into solution mode and just coding a chatbot, she sat down with the clinicians and the operational teams.
To actually observe their day-to-day friction.
Exactly. And I'm guessing you can figure out what she found.
I am guessing she found out the doctors were not losing sleep over patients asking for the pharmacy hours.
Not even a little bit. The chatbot was a proposed solution for a problem that barely even registered on their radar.
Wow. So what was the real issue?
The thing keeping clinicians up at night was the fact that they were completely data blind between patient appointments.
Data blind. That is a highly descriptive term. I like that.
It is, isn't it? Just think about the traditional healthcare model. A patient with hypertension sees their clinical team for maybe 20 minutes every 3 to 6 months.
Right.
But 80% of the data that actually dictates their health trajectory, their daily vitals, whether they are actually taking their medication, their physical activity.
That's all happening at home.
Yes. All of that happens outside the hospital walls.
In their living rooms, at their jobs, while they're sleeping. The hospital is basically just hoping the patient keeps a manual logbook, and actually remembers to bring it to the next appointment.
And we know how unreliable human memory and manual tracking can be.
Oh, entirely.
I mean, what happens if a patient simply forgets to monitor their vitals for a week? Or they skip their medication because they feel fine that day?
Or maybe their home blood pressure cuff breaks and they just don't bother fixing it.
Exactly. And in all those scenarios, the hospital remains completely in the dark.
Until it is too late.
Right. The hospital only discovers the missing data weeks later at the next checkup. Or, much more tragically, the first warning sign that a patient has stopped managing their condition.
An emergency.
Yes, is when they come crashing through the doors of the emergency room with a severe complication.
Wow. So the problem was never really about answering patient questions at all.
Yeah.
The core issue was what we might call silent risks. These health crises are just brewing quietly in the background, completely off the radar of the healthcare providers.
Because the data isn't moving from the patient's living room to the doctor's desk.
Right. So this realization, I imagine, forced Raksha and her team to pivot entirely.
It completely changed the project. They asked a new question. What if the system could autonomously detect these silent health risks before the clinicians even knew to look for them?
That's huge.
And more importantly, what if the system could intervene before the situation escalated into an emergency?
That shifts the entire goalpost of the project.
Yeah.
We're moving away from simple clinical documentation, which is really just that digital filing cabinet recording what a patient says,
Right.
and moving toward clinical orchestration, which means proactively managing a patient's health based on real-time data streams.
But building a system capable of true orchestration, a proactive digital twin, it requires a remarkably robust architecture.
I would imagine so.
You can't just wire a few apps together and hope they hold up under the weight of healthcare data.
I am eager to get into the mechanics of this, because it is easy to put proactive AI system on a whiteboard. But how do you actually wire it together so it doesn't instantly crash or, violate a dozen privacy laws?
Okay, so Raksha broke the architecture down into 3 distinct, specialized technical layers within the Salesforce ecosystem.
Okay.
Let's walk through how they interact, starting with layer 1, which is the data intelligence layer. And this is built using Salesforce Data Cloud.
Let's focus on the how here. What is Data Cloud actually doing in this specific scenario?
Its primary function is ingestion and unification. So imagine a patient using a smart blood pressure monitor at home. That device is part of the IoT, or the Internet of Things.
Meaning it is a physical object embedded with sensors that connects to the internet.
Exactly. Data Cloud takes in all those biometric readings streaming from the device and instantly links every single data point to that specific patient's unified profile.
Okay, so layer 1 is essentially the memory bank.
A very active memory bank, yeah. Then we move to layer 2, the AI interaction layer, powered by Agentforce.
Ah, Agentforce.
Right, and this is where we move far beyond a simple chatbot. Agentforce acts as the reasoning engine. It continuously monitors the massive stream of data flowing into Data Cloud, searching for trends, and it triggers engagement when it detects an unusual pattern.
So Data Cloud holds the information, and Agentforce is the brain scanning that information for anomalies.
You've got it. Then we have layer 3, the integration layer, powered by MuleSoft. Because healthcare data is, notoriously fragmented.
Oh, totally. A hospital doesn't use just one software platform.
Exactly. MuleSoft is the tool that allows the Salesforce platform to securely communicate with external third-party systems.
Like what?
In this architecture, it connects to Epic, which is a massive electronic health record system used by doctors, and SAP, which is an enterprise resource planning system that handles the hospital's supply chain and inventory.
Okay, let me just make sure I'm tracking this. So Data Cloud is the memory, absorbing and organizing all the experiences and biometric data points.
Yes.
Agent Force is the brain and the voice, doing the thinking, noticing the patterns, and deciding when to speak up.
Right.
And MuleSoft acts as the nervous system, connecting the brain to the arms and legs, those external systems like Epic and SAP, so the system can actually take physical action in the real world.
That analogy captures the workflow beautifully. But building a nervous system that relies on constant data streams introduces an immediate, massive hurdle.
Which is?
The sheer volume of data.
Ah, I can see that. A smart blood pressure monitor isn't just sending one email a day saying, everything is fine.
No, connected IoT devices ping the network constantly. Depending on the device, you might be looking at multiple readings an hour or even minute by minute.
Wow.
If you scale that continuous stream across hundreds or thousands of patients, the data volume becomes astronomical.
I can't even imagine.
If you attempt to push every single one of those routine, healthy pings into standard transactional Salesforce objects, the parts of the system meant for human interaction, you will overwhelm and crash the system.
It would be like a car's engine sending you a text message. Every single time a spark plug fires perfectly.
Exactly.
The noise would just make the system completely unusable.
So Raksha solved this using a clean core approach.
Yeah.
She separated the raw data from the actionable alerts. And for anyone curious about the specific architectural mechanics, the flow is quite elegant.
Well, let's get into those mechanics. How do you filter out the noise without losing the important warning signs?
You start by keeping the massive volume of raw data out of the core system entirely. Over 1 million IoT pings stay exclusively inside Data Cloud.
Okay.
They flow into what is called a data lake object, specifically named biometric stream dalim. Think of a data lake as a massive, unstructured reservoir where raw data is just dumped as quickly as it arrives.
So it's just collecting the millions of I am fine messages in the background.
Yes, exactly. From there, it maps to a data model object called Unified Individual Chemo.
Okay, GML.
This step basically takes that raw water from the lake and bottles. It ensures the biometric stream is cleanly attached to the correct patient's identity.
Makes sense.
But here's the critical mechanism. Raksha utilized a tool called a calculated insight, specifically Vitals Anomalishi, to act as a continuous filter.
How does a calculated insight work in this context?
Well, imagine a security guard constantly watching a bank of security cameras, but the guard is an algorithm.
Okay.
The calculated insight continuously runs calculations against the data lake, evaluating the trends against defined medical baselines. It is only looking for the risk.
Ah, I see.
When, and only when, the calculated insight identifies an anomaly, like a spike in blood pressure, for instance, does it generate a signal that leaves Data Cloud.
I see. So it ignores the noise.
Exactly. That specific, isolated signal then triggers an Agent Force health topic, which wakes up the reasoning engine to execute a fix.
That makes perfect sense. The core transactional system, where the humans and the AI actually work, never sees the millions of normal heartbeats.
Right.
It only receives an alert when a heartbeat skips. You keep the workspace clean and entirely scalable.
It handles the volume issue perfectly.
Yeah.
But, that leads us directly into the next massive hurdle, which involves the AI itself.
Here's where it gets really interesting. Because you have just given an AI the ability to monitor patient vitals, identify anomalies, and take independent action.
Yeah, we did.
But healthcare is one of the most highly regulated, high-stakes industries on the planet. I can hear hospital lawyers screaming about HIPAA violations from here.
Oh, absolutely.
How do you prevent this reasoning engine from overstepping? I mean, what stops it from accidentally practicing medicine, giving a patient incorrect advice, or hallucinating a diagnosis?
That is the single most important question when deploying artificial intelligence in clinical settings. Raksha's architecture handles this by refusing to treat AI boundaries as an afterthought. Governance is embedded directly into the foundation of the system.
How is that governance actually enforced, mechanically speaking?
Yeah.
Like, what stops the bot?
The admins configured the Einstein trust layer to act as the ultimate safety net. To use a metaphor, think of the trust layer as a highly strict, specialized translator standing between the AI and the patient.
Okay.
The AI is explicitly programmed with the persona of a coordinator, not a clinician. The trust layer holds a strict list of forbidden actions. It masks sensitive data, it monitors the AI's proposed responses, and it ensures the AI cannot, under any circumstances, generate medical advice or hallucinate a clinical diagnosis.
So the AI is allowed to say, I notice your blood pressure readings are trending high today.
Right.
But the trust layer physically prevents it from saying, you're experiencing hypertension, please double your dosage of this specific medication.
Exactly. The AI is restricted to detecting patterns, engaging the patient to gather context, and triggering operational workflows.
That's a great safeguard.
The architecture also includes automatic escalation pathways, because the moment a conversation veers into clinical territory, for example, if a patient replies to an automated check-in and says, "My blood pressure is high and I am currently having severe chest pains,"
Oh, wow.
the AI instantly stops its coordination efforts and escalates the interaction directly to a human clinician.
It has a hard-coded instinct to raise its hand and get a human doctor in the room the second things get complicated.
Yes. Furthermore, the human element of this AI interaction required just as much engineering as the technical guardrails.
So.
Well, if a machine is texting a patient about their heart rate, the experience could easily feel cold, robotic, or even dystopian.
Yeah, I would be terrified if I got a text saying, Subject 402, your biometrics indicate impending failure. That does not inspire healing.
No, it really doesn't. So to prevent that, this was not just an isolated technical build, it was a cross-functional effort. Raksha actually brought in the marketing team to design the tone of the patient journey.
The marketing team.
Yeah. They analyzed how humans respond to automated messaging and spent considerable time refining the AI prompts to ensure the agent sounded empathetic, supportive, and natural.
Having the marketing department write the system prompts for a healthcare AI is a fascinating collision of skill sets.
It fundamentally changes the user experience. By engineering the AI to sound like a caring human coordinator rather than a sterile database querying a user, they measured a 40% increase in patient engagement.
Let's walk through the simulation scenario they ran with the test patient. I believe her name in the document was Sarah.
Yes, the Sarah simulation. So imagine Sarah's at home. She lives with chronic hypertension, and she manages it using a smart blood pressure monitor connected to this new platform.
Okay.
Over a period of 2 days, Sarah goes about her normal routine. Her device continuously streams her readings into Data Cloud.
Those are the million background pings staying quietly in the raw data lake.
Exactly. During those 2 days, the calculated insight, that algorithm constantly scanning the lake, detects a gradual, steady rise in her systolic blood pressure.
Oh.
It is a clear anomaly compared to her baseline.
The system catches the silent risk.
The insight generates a signal, which triggers the Agent Force Health topic, and then the AI agent, utilizing that empathetic tone designed by the marketing team, autonomously sends Sarah a message via WhatsApp.
What does it say?
It reads, "Hi, Sarah. I noticed your recent blood pressure readings are slightly higher than usual. Have you taken your medication today?"
Pausing the scenario for a second here. Because the system identified a negative health trend and reached out to the patient to investigate, totally on its own.
Yes.
No nurse had to review a chart or push a button to send that text.
At this point in the simulation, no human clinician is even aware this interaction is taking place.
Incredible.
Now, here's where the scenario gets really complicated. Sarah replies to the WhatsApp message.
Okay.
She says, "I have been taking my meds on schedule, but my device is acting up. The battery warning light is flashing, so the readings are probably just wrong."
Oh, that is a huge twist. She is not having a medical crisis at all. Her hardware is just failing and sending corrupted data.
Right. And if you think about how a traditional basic chatbot would handle that reply, it would likely just say, "Thank you for the update," and do nothing.
Or worse, it would flag the high blood pressure reading and unnecessarily alert a doctor.
Exactly, wasting a clinician's valuable time investigating a dying battery.
A nurse would have to call Sarah, spend 10 minutes figuring out it's a battery issue, hang up, call the supply department, order a replacement, and type up the notes.
But the autonomous care coordinator is designed to interpret context. It realizes this is an operational issue, not a clinical emergency.
Wow.
And because of that layer 3, we discussed the MuleSoft integration layer, the AI can actually solve the problem. Utilizing something called invocable apex, The AI reaches out directly to the SAP ERP system.
Wait, let me push back on this. You're saying an AI is autonomously reaching into the hospital's enterprise resource system and spending hospital money to order inventory.
I know, it sounds risky.
How does the finance team feel about a chatbot going on a shopping spree?
That is exactly why Invocable Apex is used. It acts as a highly restricted, secure bridge.
Okay, how so?
The developers write specific, pre-approved code blocks the invocable Apex that tell the AI exactly what it is allowed to do in external systems. The AI isn't freely browsing the inventory.
Yeah.
It is executing a tightly controlled permission slip to perform a single authorized action replacing a registered device component.
Ah, I see. It is a strictly governed pathway.
It checks the hospital's inventory for that specific device battery. It locates one, orders the replacement battery for next-day delivery to Sarah's house, and then it takes one final crucial step.
Which is?
It reaches into the Epic electronic health record system and logs the entire interaction, the reason for the high ratings, and the battery order right in Sarah's clinical history.
So just to recap the timeline of this simulation, the system identified a rising health risk, diagnosed the root cause as a hardware issue rather than a medical one, checked the warehouse inventory, shipped a replacement part to the patient's home, and updated the official medical chart.
Yes.
All entirely automatically.
In under 5 minutes, with zero system downtime. And no doctor, nurse, or supply chain manager ever had to pick up a phone or log into a portal.
Think about the immense amount of friction in standard healthcare. I mean, the phone tag being put on hold, the supply chain delays, the disconnected systems.
It's endless.
This architecture bypassed all of it. It fixed a hardware problem that was creating false medical data, it prevented a potential future panic for the clinical team, and it did it seamlessly.
And when you look at the hard results, the KPIs that Raksha shared in the executive summary of the document, you see the real-world impact of removing that friction.
Let's hear them.
This architecture resulted in a 60% reduction in manual check-in calls by the nursing staff.
A 60% reduction is staggering. Nurse burnout is one of the most critical crises in healthcare right now.
Absolutely.
Nurses spend countless hours playing phone tag just to ask patients if they took their pills. Giving them back 60% of that time is genuinely life-changing for the staff.
It allows them to step away from administrative clerical work and return to top-of-license clinical care. They can actually focus on healing.
And on the patient side.
The metrics are equally impressive. They recorded a 25% improvement in medication and vitals tracking compliance. The system just acts as a gentle, constant guardrail, keeping patients on track.
So what does this all mean? If you are listening to this right now, whether you are a Salesforce developer writing Invocable Apex, an architect designing complex data models, a business leader trying to solve operational bottlenecks, or honestly, just an individual who occasionally has to navigate the healthcare system.
Right.
This matters to you.
It matters because it represents a fundamental evolution in our relationship with data. Technology is no longer relegated to being a passive ledger where we simply record our failures or broken hardware or our medical emergencies after the fact.
We're shifting away from reactive infrastructure where we just sit around waiting for things to break or people to get sick and moving toward active, intelligent ecosystems. Systems that observe, interpret context, and act to prevent the break from happening.
Raksha used a brilliant phrase in her documentation. She called it a shift to data-driven survival.
Oh, I love that.
That phrase perfectly encapsulates why this proof of concept is so vital. By utilizing Data Cloud as the memory, Agentforce as the reasoning voice, and MuleSoft as the nervous system, she built an active safety net. It is designed to ensure that no patient falls through the cracks of what is an incredibly complex, often overwhelming healthcare apparatus.
It is a remarkable piece of architectural design. And we started today looking at a very basic, almost mundane stakeholder request for an FAQ chatbot.
And look where we ended up.
Exactly. We unpacked how Raksha Sanganee's deep expertise and vision transformed that simple ask into a 24/7 digital twin that proactively manages human health. It serves as a masterclass in looking past the initial requirement to uncover the real problem, those silent risks, and building a scalable, ethically governed solution.
As we conclude the deep dive, I think there is a broader lesson embedded in this architecture that extends far beyond the healthcare industry.
For sure.
We just explored how an AI predicted a potential medical crisis, investigated it to discover it was merely a dying battery, and then autonomously resolved the issue.
It caught a completely silent risk that would have otherwise polluted the data and wasted everyone's time.
So, my challenge to you is to examine your own life, your own business operations, or the specific projects you're currently building.
Okay.
What silent risks are lurking in the background of your workflows? What critical warning signs is your current data infrastructure completely missing right now, simply because your systems are not designed to look for them?
That is a phenomenal question to leave on. Thank you so much for joining us on this deep dive. Keep asking those hard questions. Keep challenging your own assumptions about what your technology should be doing for you, and we will catch you next time.